Hello everyone, today we are going to solve the problem count total set bits, which is on InterviewBit. This is a hard problem of bit manipulation. It isn't pretty hard, it's normal. So welcome to my channel, let's get started. First, let's read the problem. Given a positive integer a, the task is to find the total number of set bits in the binary representation of all numbers from 1 to a. We previously solved a problem called number of 1 bits. I hope you remember that. In that question we solved, we had to count the number of ones in a single number. But here, if we are given a number a, we have to return the total number of ones in the binary representations from 1 to a. This is basically the problem. So let's take a number n is equal to 10. Now I have written all the binary representations of all the numbers from 1 to 10, and if you count the number of ones, 1, 2, 3, 4 and so on, there are some ones from 1 to n. You should return that number. How will you solve this problem? What's the first thing that comes to your mind when you're asked to solve this problem? Yeah, that's the brute force way. We start from 1, count the bits of 1, add it to the result, and then we go to 2, count the bits of 2, add it to the result, and then we go to 3, and we repeat the process and so on until we reach the 10. So what is the time complexity? We start from 1 and go till n, and for each number we count the number of ones in each number and return the result. If we say that for counting the set bits in a number takes constant time, if we say that, then the time complexity for solving this will become big O of n, because we are starting from 1 and going till n. For every number we are counting bits, which is taking a constant time, let's assume. So it will take a big O of n time, which if we solve this in a brute force way. Now can we approach this problem in a better way? If you observe these binary representations, you will find one small hint to solve this problem. Now let's look at the problem in a totally different perspective. If you observe carefully, let's take the position 1. I have named the positions starting from the right, from 1. This is 1, this is 2, this is 3 and so on. At position 1, look at how bits are repeating in a repeating periodically. We have 0, 1 and then 0, 1 and then 0, 0, 1 and so on. If you look at the position 2, we have different repetition, 0, 0, 1, 1, 0, 0, 1, 1, 0, 0, 1, 1 and so on. And if you look at position 3, 4 zeros, 4 ones, 4 zeros, 4 ones and so on. This is the observation which we have to make to solve this problem in an optimized way. Now let's assume that this combination of zeros and ones which are repeating, let's take them as a single interval. For position 1, this 0, 1 becomes a single interval. For position 2, 0, 0, 1, 1 will become a single interval. For position 3, 4 zeros, 4 ones will become a single interval. Now, if I ask you to tell me the interval size at a position I, what will be that? 2 power I. At position 1, what is the interval size? 2, right? 2 power 1 is 2. At position 2, what is the interval size? It's 4. It's 2 zeros and 2 ones. 2 square, 2 power 2. At 3, 4 zeros and 4 ones. Total size is 8. 2 power 3 is 8. So we can generalize the statement that interval size at position I is 2 power I. I hope you all agree on this. Now, as you notice that in each interval, the number of zeros and ones are equal, which means the number of ones are exactly half of the interval size. This is the next formula. Please don't get scared by seeing these formulas. I'm just writing them down so that things will be clearer to you. Number of ones in an interval will be interval size by 2, as I have stated before. Now in the question it was stated that from number of bits from 1 to 10, but I have included a 0 also in this. Why? Because if we add a 0, the result won't change because 0 does not contain ones, but there is a pattern established if we add 0. Yes, you see that, right? If we add 0, there is a pattern of intervals, as we had seen earlier. That's the reason why I added 0. Now, if you are given a number, let's take 10. Until 10, how many numbers are there, including 0? Until 10, how many numbers are there, including 0? If you are given a number n, then you will have n plus 1 numbers, including 0. Are you with me? Yes, right? Now, for the number of complete intervals for a given number is n plus 1 by interval size. Now, let's take n is equal to 10 and position is equal to 1. Position is equal to 1. How many intervals of position 1, how many complete intervals of position 1 are there in the number 10? Until this, there is an interval 1, 2, 3, 4. There are 5 complete intervals. This is not a complete interval, right? Until this, there are 5 complete intervals. And how do you get that? The number of complete intervals will be n plus 1 by interval size. Alright? 10 plus 1 by interval size is 11 by interval size is 2, which is 5. So there are 5 complete intervals at position 1 for n is equal to 10. Now the complete intervals concept is clear to you. Now let's take the position 2 and find the incomplete interval size. Now I am giving to you n is equal to 10 and position is equal to 2. You just have to tell me number of complete intervals at position 2. How will you do that? Until here there is 1 interval. Until here there are 2 intervals. And this interval is not complete yet. Alright. So number of complete intervals, how will you calculate? n plus 1 by interval size. 10 plus 1 by interval size is, for position to interval size is 4. 11 by 4 gives you 2. So there are 2 complete intervals at position 2 for n is equal to 10. Now complete intervals concept is clear to you. Now let's look at incomplete intervals size. So for n is equal to 10 and position 2, this is the incomplete interval. Do you agree on this? Now, how do you find that size? It's just the remainder, right? So what will you do? The total numbers mod of interval size will give you the remainder. In the earlier case, this was the quotient. Now we are getting the remainder, which is not complete. So that's the size of incomplete interval, right? Now, how do you get the number of ones? I have already explained it to you. Number of ones in an interval is interval size by 2. That's fine. For complete intervals, you can calculate the number of ones easily using these formulas. But how do you calculate number of ones in an incomplete interval? How do you calculate that? Let's take this example. For n is equal to 10 and position 2, what is the incomplete interval size? Just apply the formula. Incomplete interval size is equal to n plus 1 mod interval size. For position 2, interval size is 4. 11 mod 4 is equal to 3. Right? So the incomplete interval size is 3. Alright. Now, how many ones will be there in that incomplete interval? We previously saw that the number of ones will be the lower half of a particular interval. The upper half will all be zeros and the lower half of an interval will all be ones. So, if the incomplete interval size is 3, can we say that the actual interval size is 4 and incomplete interval size is 3? In the total size of 4 by 2 size is occupied by zeros. Will you agree on this? Right? Now, how many ones will be there? The number of ones will be the remainder minus interval size by 2. Interval size 4 by 2. That's what I have written here. This is nothing but the remainder. This and these are same. The remainder minus interval size by 2 will give you number of ones in an incomplete interval. So we have seen a lot of concepts here. I hope you did not get confused. So let's look at the code. You will get more clarity. So I'll show you the code. Wait a minute. Maybe I'll just revise once. We have first seen the interval size. How will we calculate the interval size for a particular position using this formula? And number of ones in an interval will be interval size by 2. Number of complete intervals for a given n will be n plus 1 by interval size. That also we have seen. Now, the incomplete interval size is calculated using this formula. And number of ones in an incomplete interval is calculated using this formula. These are not formulas at all. I have written them in the form of formulas, but they are general things. If you put some logic into the problem, you will understand that. Now let's look at the code. Here we go. This is a first hard problem. I am getting excited. So we are given an n, and I am storing the total count of bits in the result. Here in the question it is stated that the result may overflow. So he asked us to use modulo. I'm taking a mod variable here. Now what I'm doing is the I represents the position. I am coming from the rightmost position to the leftmost position in the binary representations. For each position, I'm calculating the number of ones and adding them to result. That's what I'm doing here. For each position, I'm calculating the number of ones at that position and adding them to the result. So first, the formula of interval size is 2 power I for a given position. That's what I did here. And number of complete intervals will be the given number plus 1 by interval size. That also we have seen. Now incomplete interval size is n plus 1 mod of interval size. This is nothing but the remainder which is remained after dividing with interval size. Now the previous ones are nothing but the number of ones in the complete intervals. I'm repeating it. Previous ones are nothing but the number of ones in the complete intervals at a given position. So number of ones in an interval is interval size by 2, that I have discussed in the explanation part. Number of ones into number of intervals will give us the total ones for total complete number of ones in complete intervals. So we have got the previous ones, and the last ones denote the number of ones in the incomplete interval. Now if incomplete interval size is calculated using that formula, if incomplete interval size is greater than interval size by 2, because until interval size by 2 there are only zeros, there are no ones, right? If the incomplete interval size is greater than interval size by 2, then we have some ones left for us. And to calculate the number of ones in an incomplete interval, the formula is incomplete interval size minus interval size by 2. This also I have discussed in the explanation part. If you get confused, please look at it once again. Now I am adding the total ones, previous ones plus last ones, to the result, and I am taking care of the overflow using modulo operator, and finally I am returning the result. So I have covered pretty much everything in this problem that is to be explained. I hope you have understood the problem and the solution. So please drop a like, share and subscribe to my channel Algo Conqueror. Thank you very much.